Hello everyone, so today we're going to talk about why the area of a rectangle is length times breadth. Why the area of a rectangle, rectangle is length times breadth. Okay. So before we answer that question, we need to ask another question, which is actually, how do you measure area? How do you actually measure area? And also, before answering that question, we also need to ask another important question, or simpler question, I guess, is to how do you measure length in the first place? How do you measure length? So this is my length, let's say. This is the rod of whose length I need to measure, right? So how do you all measure it? What we do, we take a unit length, and in terms of that unit length, we actually measure the whole length. So we place our unit length side by side and count how many unit length we need to arrange side by side to get the whole length. So in this case, let's say it is approximately 1, 2, 3, 4, 5, 6, 7. We need to arrange 7 unit lengths side by side to get the length of my rod. So we say the length of the rod is 7 unit rod. 7 unit rod. In this case, unit rod, I can call my unit rod a centimeter, so you can call it 7 centimeter. The length of the rod is 7 centimeters. So what we do, how do you measure actually the length, is we take a unit length which is present to, which is, so how do we actually measure the length? We have our unit length, which is centimeter, let's say, and we all have that. And we just take any length and we compare it with our unit length, and that's how we actually measure it. So we measure length in terms of a unit length. We measure length in terms of a smaller unit length. So the next question I need to ask is that, can I measure area in terms of length? So let's draw a unit area, let's draw an area, an arbitrary area, anything, any kind of area you want. And is there a way I can measure this whole area in terms of the length? Well, if you try doing that, well, you'll find no, there is no way I cannot really measure length, an area with a length. So now we run out of tools to measure area. So we define another tool. Let's like the length, like the rod's length. We have defined a unit length first. What if we define unit area first and then try to measure the length? Area. So this is our area, the area we wish to measure, and we have to define now unit area, like a unit length. So how do we define it? The most obvious or most beautiful way to do this is to define a square. Define a square whose length is of unit length, whose sides are of unit length. Okay, whose sides are of unit length. I think you should draw it here. So this is my unit area whose sides are of unit length. Sides are of unit length. This is my unit area. Now what I do, I just place this unit area here as much as I want until I completely fill this rectangle's area. Okay, so what I'm gonna just try to feel So okay, so this is, let's say this approximately placed my I have filled this whole area, rectangle area, with the small square area. Okay, with the small squares. Okay, so now how many squares are there? How many squares are there? I'm gonna just measure that first. 1, 2, 3, 4, 5, 6, and there is 1, 2, 3, 4 rows. So 6 times 4, which is what, 24, right? So there are 24 squares. We needed 24 squares to actually completely fill this rectangle. So we say that the area of the rectangle is 24 squares, small squares of unit length. 24 squares of unit length. So now we give a name to this unit area. We call it centimeter square, because the length of our unit is centimeter. Unit length is centimeter. We call the unit length centimeter, so we're gonna call it centimeter square. So we can say the area of the rectangle is 24 centimeter square. So we can say the length of our rectangle is 24 centimeter square. Now obviously you're gonna say, okay, I can do it by putting the unit area inside this, whole rectangle. But how does it justify the formula length times breadth? Now, if we look at what does length and breadth means, well, in terms of the square, then okay, so the length. Let's say this has length of 6 centimeter, and this has length of 4 centimeter. So what does it mean? So 6 centimeter means that I can actually fit 1, 2, 3, 4, 5, 6, 6 squares side by side. Okay, so it means each row, let's call this row, there are 4 rows, so each row has 6 square. This information is actually my length. And how many rows are there? Number of rows are what? 4, right? 1, 2, 3, 4. This information is actually the breadth. Now, I didn't count the whole thing, right? 1, 2, 3, like I didn't count each of them. I just counted the number of square in each row and how many rows are there, and then I multiplied them. So okay, how do you count that? So the number of total squares equals number of square in each row times so number of square in each row times number of rows. So what is number of square in each row? This is actually my length. 1, 2, 3, 4, 5, 6. So 6, and number of rows is actually 4, and that's how I get 24. So that is why we always say I don't need to do this whole math. I don't need to just take the square and fill the whole thing with smaller squares than to count up. If we have this two information, length and breadth, we can just multiply them to get the number of squares I can fit my rectangle with. So this is it. This is the whole picture.